Hello, welcome. Our third circuit is what I call the main trapdoor or the security door system. This is normally used in banks, used in secure areas, and used in buildings, high-rise buildings, where you have two doors. One, the entry door that you open, you get into a compartment, and then the first door that you entered with is closed, locked, and then the second door opens. Then you can enter now the premises, and then it locks. So this is normally used in banks and many places for security where you have double doors. So this is a system using PIC16F84 like the one we used for alarms. And remember, the same rules apply. First, before we go into the operation of this circuit, our text. This is our text. Electronic waste benefit, our philosophy. And remember, use as much waste as possible from electronic waste. Computers, radios, TVs, telecommunications equipment, home equipment, domestic equipment, industrial equipment. You get components from there, use them. Let's recycle. Now, a warning. This is also an area where you need experience. Electricity is very dangerous if you don't know how to work with it. So please make sure you have someone experienced working with you, or if you are experienced, that's okay, you can go on. And remember also, this is not a training on electronics. You need prior knowledge of electronics and electrical engineering to do this circuits. This is also an expectation that you are 10 years and beyond. This is from experience, although you can be younger, but suppose 10 years is good enough that you understand some of the concepts that we are talking about here. Right, now this is a share on the description of the circuits that I have done that I would want to share with you. It's not a lesson on electronics or any form of engineering, although we are going to talk about engineering terms and all that, but we are not going to talk much about how, why and where, but mostly the description of the circuits. The philosophy: use much waste as possible, as always, and this can be used for training and used for learning aid, used at home, used for industrial applications, wherever you find it suitable for you to apply it. Resources needed, since like before the circuit number 2, the alarm, you need just about the same, and this is also a flow code version of the project. And I expect that you would enjoy it. Thank you very much for your time. So here is the circuit. The circuit works pretty much like this. You have two doors with limit switches. There is the entry door, the door that you enter on, and then with a limit switch, and then there is the exit, the inside door. The inside door is the door that is inside the premises, or the second door as you enter. Remember also, this circuit is a replica of the exit setup, where the entry door becomes the door that you actually first encounter when you are going out, and then the inside door is actually the exit door when you're going out of the premises. The key switch is a security switch. You can use the electronic lock like the first circuit, or you can use a remote control, you can use a key switch. This is the security system, and remember, as always, security switches are break switches. So if you break, you are actually activated. If you are making, you are actually deactivated. So this is also using a reset to the PIC. So a low here will actually reset the PIC. It will program stop run. If you break it, the program starts to run, and it will actually drive a relay driver here, transistor array, to drive the two relays. And because here is running a program which I'll show you, it will actually be driving the driver to activate appropriately the relays to lock or unlock. They can be electric, they can be electrically activated, latching or whatever you can use, or a signal that you send to say lock or unlock. But remember, the locking system normally is also operate to unlock. That's a fail-safe system. It operates to unlock, not operate to lock. Because if there is no power, then you have a problem, you have a security issue. So it's operate to unlock. So what happens is this PIC is running a program. If you open the entry door, you are entering the building. Open it, because in the morning by the time, can be a timed key switch or manually controlled. After, let's say, 8 o'clock, the key operates to run a program which you show on the simulation. This is actually active. It means the entry door is actually unlocked. So you open the door, it activates, it sees that the door is open, and then it locks. Make sure this door, the inside door, is locked, and then once you open and close, it locks this door, the entry door, and after some seconds opens and or unlocks the inside door so that you can get out into the premises. And whilst this one is open, this one is surely made to be in lock position, and then only until this one is closed, then this one opens. So you have these two sensors that actually sees. You can modify this to suit what you need. I'll show you the program done in flow code 7, and you can modify it. I was limited by the number of blocks that I can use in the free version, up to 20 blocks. So this is how it works. One door is open at any given time, and on idle position, if the key switch is in run mode, the outside door is open always, and then it allows the entry into the compartment, and then alternates the locking and unlocking of the doors. So this is how it works in simulation. Right, we have that same circuit. Let me try to zoom it so that we are all in picture. Maybe the power line is not a problem here, it's just a power supply, and the relay is here. You will see what happens. So I start the simulation, because here is a program that is running that I load in like before in the alarm. Please check the alarm circuit if you are not familiar with how to load the programs into the PIC. Just given a hint there. So this is in deactivated position. You can't do much here. Even if you open the door and close it, nothing happens. Check the doors, they are all in lock position. So it's operate to unlock. So when it's not operated, it is locked. This door is locked, that door is locked. So only when I do this, now you see relay number 2 is operated, so this door is unlocked. The program is now running, so you can enter, which means if I go like this, I enter, open and close. Maybe 1, 2, 3 people getting in. You can add some security to say, okay, maybe minimum number of people, maximum number of people, whatever. And then you are now in the community. Remember, that one now is locked, and this one unlocks after some seconds. And then it gives you time. If you don't open this door, and enter, it will unlock, it will lock back. So I end out and exit. So you see here it is locked. Then after some seconds this door is now unlocked again because I have opened this inside door and closed it. So it prepares for the next entry. So I enter someone, another person now is entering, and remember, so it opens and closes. This one opens. Let's suppose this person does not open the door, maybe it's confused, it doesn't know what is happening, which is usually the case. It will give you time and then it will lock back the door and open this one. Locks and open that one. Now this person is now confused, so this person must actually be told to actually go back. So you must, or maybe just open this door and close it whilst inside. And you see now it actually opens, allows you to now exit. Right, so this is how it works. It's as simple as that, and there is a program for that. And these are limit switches. Then don't need to be changeover. It can be just a straight limit switch on off, activated mechanical or whatever switch, you magnetic sensor or whatever. These locks can be on any form. So this is how it works. Simple as that. And here is the program in flow code. I stop the program here. Here's the program in flow code. Yeah, the door, input door, like the alarm system. That's the outside door. The entry door, entry limit switch, decision making is the limit switch on or off. If yes, then it executes the program. If it's not, then it goes to connection B, comes back. You see, where's connection B? Here, comes back here. So it's waiting for you. It's waiting outdoor 1, which means it's activated, it's unlocked, because it is actually running. The program is on as you remove the reset, clear signal. Its program is running, so it checks this door. If this door is open, the limit switch checks the limit switch. Is the limit switch operated? If yes, it's operated, then it goes to here, the connection C. Here, the entry limit switch, right? Entry limit switch is the limit switch. Again, another decision here. Is the entry limit switch? Yes. What is it in position? Is it yeah, let's say okay, P3 is the limits. Remember this one, it checks again this limit switch. If it's operated, go to C, comes back. So it's still operated, it means this door is still open, so it always checks this door is still open, this door is still open. If not, it means now the switch is closed. Here, limit switch open, yes, okay. It checks again. Here, no. Now the door is closed. Out door, lock now. Now it's locked. Then delay 2 seconds. In door, open the other door now for you to go in. Then if that in door is now on, it's unlocked. So delay 10 seconds. If it delays 10 seconds, and then inside door, inside limit switch checks the inside limit switch, because it gives you time to actually open the door and go in. If the limit switch here, this is a decision. It's a condition. You can check from here where the input, right? The input limit switch. If it's operated, right? Okay, out. Then it locks that one and then goes back to there. If it is if it is not operated, which means the limit switch is still sorry, getting lost here, right? If the limit switch, is it operated? If it's yes, then port B go to 0. It means it reset the output, meaning all the output, and goes to port A, which means it actually also gives you a delay. So it's just checking the inside limit switch, which is the door to get in. And then here, if it is now closed, then it delays 3 seconds, and then the door is now delays 3 seconds, and then goes to connection B, comes here and says, okay, go to connection B. What is connection B? Connection B is start from there. It means it starts the program again. It means everything now goes to normal. So here is the program for on the flow card on the door. So it always is checking and delays. If you do not open the door, especially the inside door, it locks it back. Yeah, that's the program. It locks it back. If it opens, then it actually open and close. It open and close. It's here, and then it actually allows the next person to enter. And then here, if you don't open it, it just locks it. You must actually now open the entry door and close it, so that you activate the inside door. So this is the flow code program. Like the alarm, well, you can simulate it. You can compile it to X, which is normally the code that you want to burn into the PIC, and configure the PIC. Remember, choose the 84A, which is the free version, and configure the frequency where it is running here. How you configure it? You go to build and then project options. You go to project options, and then I'll just show you, but it's out of interest. Here is the clock 4 megahertz here. Choose the target. You can choose here on the free version. That's how the new version of flow code is. General options, and pretty much other things just leave as they are. Right, oscillator, high-speed oscillator. We are using a crystal oscillator here. So you can check that, and whether you use the internal, because this one normally doesn't have internal, I guess. Yeah. So this is the flow code program. Now, yeah, that's pretty much about it, and nothing more to this. The simulation we have done. The circuit, here is the circuit. Pretty much practical circuit. Here 5 volts, well, because now everything is powered 5 volts. Remember, the PIC is powered in 5 volts. You can choose 5 volt relays, or you can separate the power here and actually power the relays separately, 12 volt. But remember, you must power the PIC with 5 volts. And here the driver, normally here the inputs can take up 5 volts low voltages, but the output, the common here, must be the power for the relay, the positive that you power for the relay. So yeah, this is what it is, plus minus. So feedback, please, as always, this is my email. You can feedback. I'll take time, but I'll make sure I'll respond to questions, and maybe comments are welcome. Bad and good comments welcome. Well, they make it possible. They make improvements possible, and I hope you enjoy doing this as much as I have enjoyed. I have done this circuit, well, just out of maybe interest, but I hope you will find application for it. Thank you.